Okay, so this is part 2 of the final exam review, fall final exam review for Integrated Math 3. Let's get started. I'm going to start with problem number 11, part C and D. Okay, here we go. Alright, so part C is asking us to graph and describe, just like part A and B. Graph and describe the transformation from f of x to g of x. Okay, so I'm going to start the same way that I started the other ones by figuring out the value of b, h, a, and k. Those are my important things that I need to find right now. So b, if you guys look in here, b would be next to the x in here. There's nothing in there, so that means that b is 1, which really means that you don't have to care about it. Okay, it's not going to make a difference in your graph. H is in the radical with the x. It says x minus 1. That means that h is equal to positive 1, not negative 1. Positive 1. Next is A. A would always be in front. There it is. It's 2. And finally K. K is the number that's always kicked out at the end. That is 2. So that means that B and H are going to affect the X values. A and K are going to affect the Y values. The next thing you need to do is figure out your parent function table. This is only going to come to you from memorizing those tables that we learned earlier in the year. Okay, so the parent function table for a cube root function, not a square root function. Okay, notice the difference between this, which is cube root, and let's go back to 11b. This is cubing, right? The cube of a number. So when you cube a number, that means you make it bigger, right? If you have with negative 2, then you make it negative 8. It becomes a bigger number. Negative 1, negative 1. 0, 0, 1, 1. 2 becomes 8. But cube root, the number should get smaller. You're finding the cube root of a number. So you don't start with negative 2 and turn it into a negative 8. You do the exact opposite. You start with a negative 8, and the cube root of it is negative 2. Negative 1 gives you negative 1 also. 0 gives you 0. 1 gives you 1. And 8 gives you 2. So if negative 8 gives you negative 2, 8 gives you positive 2. There you go. And we're going to use that to transform our graph. It's going to transform into something brand new. Here we go. So first, you start with the x values and you look at b and h. Multiply times 1, add 1. Now you know what? Multiplying times 1 is not going to do anything, so I'm just going to go ahead and add 1, and that's it. So, negative 8 plus 1, negative 7. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 8 plus 1 is 9. There you go. All of these numbers, we added 1 because of h. Next, the y values. According to this, we're going to multiply times 2 first and then add 2. So times 2 plus 2, times 2 plus 2, times 2 plus 2, and so on. So let's start with the negative 2. Negative 2 times 2 is negative 4, plus 2 gives you negative 2. Do the same thing for the negative 1. Negative 1 times 2 is negative 2, plus 2 is 0. Alright, 0 is the next number. Times 2 is 0, plus 2 is 2. Next we have 1. 1 times 2 is 2, plus 2 is 4. And finally 2. 2 times 2 is 4, plus 2 is 6. There you go. Now let's graph it. I'm going to graph the original function in black, how I made the numbers, and the transform function in red. So let's do the original function first. Negative 8, negative 2 is right here. Negative 1, right here. 0, 0, right on the origin. 1, 1. 1 to the right, 1 up, right there. And 8, 2, right there. And so our line goes like this. Kind of missed those points there, but that's the shape that it takes. Next, the transformation. -7, -2 is right about here. 0, 0, right here on the origin. 1, 2, right here. Fill that in. 2, 4, right here. And 9, 6. 9, 6 is way over here. And so you have a line that goes like this, hits those, and then it goes that way like that. There you go. So let's describe what happened. I'm going to use the B, H, A, and K to do the description. You could also look at the graph and notice what happened. For example, look at these 3 points that are in a line, and these 3 points for the black line that are in a line. The center point pretty much tells you what happened, what moved. It looks like the point that used to be here moved to the right 1 and up 2, which is exactly what we expect right here. H is 1, K is 2. That means a shift to the right. That means a shift up. Okay, let's write those down. So H is 1. That means a shift right 1 unit. Shift right 1 unit. Next, A is 2. That means a vertical. It's positive, so it's just a stretch. Vertical stretch. Stretch because it is a number bigger than 1 by a factor of 2. If it had been a negative, we would say it's a vertical stretch and also a reflection. But it's not, it's positive, so it's just a vertical stretch. Alright, and finally K. K is positive 2, so that means that it's going to be a vertical shift, right? So it's going to be shifting, in this case it's going to be shifting up because it's K. K is vertical. Shift up 2 units. And if you look at the graph, that's exactly what happened. It shifted to the right 1. It stretched. You can see that there's a vertical stretch. The difference between points vertically has been increased by a factor of 2. And it also shifted to the right 2 units. I mean up 2 units. Alright, for part D, I'm going to let you guys work on it. The only thing I'm going to help you out with right now real quick is to give you guys the correct parent function table, which you guys need to review, study those tables so you remember them by the final. For a square root function, the parent function table should be 0, 0, 1, 1, and 4, 2. That should be enough. No negatives in the x values because you cannot plug in a negative into the radical without getting imaginaries, and we don't care about imaginaries when we're graphing. Okay, go ahead and use that parent function table, find B, H, A, and K, and then go ahead and transform it. Alright, here's the correct solution for part D. I came up with B equals 1, H equals 0, because there's nothing in their radical with the x, right? It's all by itself. That means that B, which is next to it, is 1, and H, which is supposed to be added or subtracted, is 0, because there's nothing being added or subtracted. Which means that these two really don't make a difference in your graph. The only ones that matter are A and K. A is in front, right here, -3, and K is over here at the end, which is -1, right there. I mean positive 1, not -1. Using those two and the table, parent function table that I gave you guys, I made the transformation. All I had to do was leave the x values the same because there's nothing with B, nothing with H, but change the y values by multiplying by -3 and then adding 1, right? Times -3 plus 1 gives me 1. 1 times -3 is -3 plus 1 gives me -2. 2 times -3 is -6 plus 1 gives me -5. So I plotted those points, and that's this graph, and this is the original. And then I did my description. The first thing is I look at the A. If A is negative or B is negative, then there's two things that it's doing. First, the negative makes a reflection. Reflection across which axis? The x-axis, because it's a vertical reflection. Think you're doing a vertical reflection, that means you're jumping over the x-axis. So that's why it used to be facing that way. Now it's facing this way, right? Then the 3 makes it a stretch, vertical stretch by a factor of 3, because it's a, it's not a horizontal stretch, it's a vertical stretch. And then k shifts it up 1 unit, and you can see that is exactly what happened. The initial point here went up, it shifted up 1 unit, and that is your final graph. Alright, let's move on to number 12. It says identify the rational zeros of each function, then write the function in factored form. So here we go. I'm going to start with A. So I'm going to start by listing all the possible factors that we have. You look at the constant at the end right there, the -5, and the factors of -5 are plus or minus 1 and plus or minus 5. That's it. The factors of your leading coefficient, which is 1, is just 1. So plus or minus 1. Right? The leading coefficient is 1, so the factor is just 1, plus or minus 1. That means that what you're going to be testing, the testing values are just basically those two. Plus or minus 1 and plus or minus 5. So there's really not that many to test out. Perfect, that makes it a little bit easier for us. Okay, so I'm going to set it up for test for synthetic division so I could test out which ones are going to work. And I'm going to start by testing positive 1. Okay, so my values are, my coefficients are 1, -7, 11, and -5. And let's test, bring down the 1. 1 times 1 is 1, -6. 1 times -6 is -6. That's 5. 1 times 5 is 5. Look at that. We found it on the very first try. That is the remainder, which is 0, which means that the first 0 is 1. X equals 1. Alright, I'm going to write that over here. That's the first one we find. We need 2 more, right? Because this is a cubic function. So that means that there's 2 others. Now, you could continue to test out values using synthetic division right here. Right? Test something else. But since I started with the cubic and now this is a quadratic, what I'm going to do instead is just change this into a polynomial. It's a quadratic polynomial, x squared minus 6x plus 5, and I'm going to try to factor it. We know how to factor those. 1 times 5 is 5, b is -6. 2 numbers that you multiply to make to make 5, I mean, but add up to make -6. 2 and 3, -2 and -3, right? -2 times -3 is, no, that doesn't make sense. Let's erase those. Those are completely off. They have to multiply to make 5. So 5 and 1 is my option actually. -1 and -5. Which when you multiply them they make +5, and when you combine them they make -6. Yes, that is correct. So -1 and -5. Okay, so that means that my polynomial is now x squared minus 1x. Let me show you guys that so you can see clearly where that came from. Minus 5x plus 5. So the -1x and the -5x both came from here. And now what we're going to do is we're going to group these and group these to factor out the GCF. So for the first pair, the only thing I see that they have in common is x, so factor out an x, leaving you with x minus 1. For the other pair, they look like they have a -5 in common, so that's going to be x minus 1 also. So my factor, the common factor that they have is x minus 1, so it's going to be x minus 1, x minus 5, which gives me my solutions, which are going to be x equals 1, x equals 5. Now those two are in addition to the one we had already found before, right? So it's x equals 1 twice, and then x equals 5. Those are the 3 of them. Now it says identify the rational zeros. We found them. Write the function in factored form. Okay, so put those zeros in factored form. So it's going to look like this. X minus 1 is the one that gave me 1, right? But there's 2 of them, so it's actually x minus 1 squared. And then what gave me 5? X minus 5. There you go. That is the factored form of the function, and the zeros are the ones that I boxed in yellow. Okay. Now, for the zeros, since one of them repeats, we would say that x equals 5 and x equals 1 multiplicity 2 because it happens twice, right? So it would actually be this right there. That's how you would write your solution. Alright, I'm going to let you guys figure out B. So go ahead and try it out on your own first, and then come back and watch the correct solution. Okay, so go ahead and pause the video now so you could try it on your own. Alright, here you go. This is the correct solution for part B. What I did first is I came up with all the factors of the negative 2 over here at the end, the constant, which is plus or minus 1, plus or minus 2. Then I came up with all the different factors of 6, which is the leading coefficient, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then I tested them. The first one I tested was 1, and it didn't work. Then I tested negative 1, and it didn't work. And then I tested 2, and it did work. Oh, by the way, I forgot to mention this. When you test the values, remember that you're always testing the ratios that come from the factors of the constant divided by the factors of the leading coefficient. So this number over this number, all the different combinations you can make. So 1 over 1, 2 over 1, which is plus or minus 1 and plus or minus 2, 1 over 2, 1/2, 2 over 2, which is 1 again, so I didn't write it again, 1 over 3, which is 1/3, 2 over 3, which is right there, 1 over 6, oops, I forgot to write that one there, it's also plus or minus 1 over 6, and 2 over 6, which is 1/3, but I already wrote it, so I didn't write it again. So those are all of the values that you would need to test out, okay? The combination of this number divided by factors of this number divided by factors of that number. Thankfully, I tested plus or minus 1, I tested positive 1, it didn't work. I tested positive negative 1, it didn't work. So the next one I tested was 2, and it did work. Once that one worked, I took this 6, 5, and 1 and made it 6x squared plus 5x plus 1, and I used x factor to factor it out. Once I factored it out, I grouped them right here. I got 3x plus 1 and 2x plus 1, and that gave me x equals negative 1/3 and x equals negative 1/2. So as expected, they are values that we had already come up with by testing them. Okay, so if I had skipped 2 and went ahead to test negative 1/3, it would have worked, or negative 1/2, it would have worked also. So my final factors are the 2 that I got from here, and these 2 that I got from this factoring part. Okay, those are my 3 factors. I wrote them again right here. And then it also says to write it in factored form, so I just left that this one came from the 3x plus 1, this one came from the 2x plus 1, and this one comes from x minus 2. And that is your final solution. Okay, 13, solve. Then state the multiplicities of each root /0 /intercept, which is the same thing. So they want you to solve these equations and then tell us what the multiplicity is. These are actually pretty simple because they're already factored. So all you got to do is set them equal to 0 equals x squared, x minus 1 squared, and x plus 2 cubed. Just solve each part. Set each part equal to 0. Most of you guys can do this in your head. You must include this one, even though it's by itself, it still has an x. If it has an x, it has an x-intercept or a 0 or a root. So the first one is x squared equals 0, which gives you x equals 0. Multiplicity for that one is 2 because of the x squared. There are 2 of these zeros right there, right? This actually means x times x equals 0. So each one of those x's is 0. Now do the same thing for this one. So x minus 1 squared equals 0, which means that x equals 1, correct? Multiplicity for that one, also 2, because there are 2 factors that give you that 1. And finally, this one, x plus 2 equals 0, x plus 2 cubed equals 0, x plus 2 cubed equals 0. That one is going to give you x equals negative 2. And the multiplicity of that one is 3 because it happens 3 times. We only really give multiplicities if it's more than 1, okay? But don't be surprised if you see multiplicity once sometime, which means that it only happens once, okay? But if it happens more than once is when we really care about it. This one happens twice, this one happens twice, and this one happens 3 times. Alright, I'm going to let you guys work on B. So go ahead and try it out on your own. Figure out what the zeros are and what their multiplicities are. And then come back and see the answer. Go ahead and pause the video. Alright, here you go. These are the correct solutions. The only one that I think you guys would be confused about is this one because of the -4. But just remember that if it's x squared, I mean if it's just the x by itself, what you do is divide by -4, which leaves it as 0, and then you take the square root, which is still 0. So either way, you're going to get x equals 0. That's the only way that one could work. And the multiplicity, once again, is 2 because of x squared. Here it gives you -1, and the multiplicity is 3. And here it gives you -2, but the multiplicity is 4. And remember, how does that help us? Okay, the point of these problems is to get you guys to see the multiplicities so that when you graph them, you can tell if it either crosses or touches. So in this case, it's going to be tangent or touches, right? Because the multiplicity is even. This one also is tangent. And the last one crosses because the multiplicity is odd. We look for the multiplicity, not for the value of the number. This number is odd, but it has nothing to do with if it touches or crosses. The multiplicity is the one that tells you. Even is tangent, odd crosses. Over here, in the one that you guys did, x equals 0 would be tangent. X equals -1 would be crosses. It would cross. And x equals -2 would also be tangent because of their multiplicities. Alright, 14, write a polynomial function of least degree and leading coefficient 1 that has the given roots. So it has to have these roots right here that they gave us, and the leading coefficient has to be 1, and it has to be of the least degree possible. Okay, here we go. Let's start with A. In A, they want a function that has those zeros, right? But what I notice is that there is a 2i, and whenever you guys see an imaginary or an irrational number, like over here in C, so an imaginary or an irrational number, that means that there has to be a conjugate. The conjugate of 2i is -2i. So you must include it as part of your factors, part of your roots. So there has to be a third one there. And now you just plug in all the values, right? If you have a 2i, then you must include the -2i, therefore there are 3. So it's going to be x minus 1, x minus 2i, and x minus -2i, which is actually going to make it plus 2i. And now we're just going to multiply them out. Multiply these two first. X times x is x squared. X times 2i is 2ix, or 2xi, same thing. That's that one. 2i, -2i times x is -2ix. And finally, -2i times +2i is -4i squared. We're going to simplify that. That's just x squared. The -2ix and the +2ix cancel. And -4i squared is going to be -4. I squared is just -1, so it's -4 times -1. So then that final part is x squared plus 4. We're going to multiply that times x minus 1, which is the one over here that we haven't touched. And that'll be our final multiplication here. X times x squared is x cubed. X times 4 is 4x. That's that one right there. -1 times x squared is -x squared. And -1 times 4 is -4. Put them in standard form, which means that these two need to be switched so that they're in order. And it's going to be x cubed minus x squared plus 4x minus 4. There you go. That is your final, I think it was called f of x, function. Oh, they didn't tell us what to call it, so I'm just calling it f of x. And that's your final function for that one. Okay. What you have to remember is that every time you see an imaginary or a radical, you have to include the conjugate. Okay, and you change the sign of the imaginary part or the radical part. You do not change the sign of the constant part. Alright, so for part B, I'm going to let you guys work on it. I'm going to help you out by finding the conjugate for you because this is something that a lot of people get confused on. The factor is 2. This is one number only. Yes, there are two terms in it, but it is one number. It's 1, which is the real part, and 2i, which is the imaginary part. But combined, they are really one number. A lot of mistakes that I saw in previous tests is that people were going to be doing this. X minus 2, that will be that one. And then they would do x minus 1 because of that one. And then they would do x minus negative 2i because of that one, which is going to make it positive, right? And then they would say, oh, well, negative 2i means that there's also a positive 2i, so they would add a positive 2i also to the mix, and then they would say, oh, it's x minus 2i also. And they have 4 factors all of a sudden, okay? And it's not. This one right here is only one term, okay? One number, so the conjugate of it will be 1 plus 2i. So this is not correct. This is not the conjugate you need. The conjugate you need is 1 plus 2i. You don't need those parentheses. And now you have three roots, 3 zeros. So you only need 3 parentheses. Okay, go ahead and try it on your own, and then come back and check your answer. Go ahead and pause the video now. Alright, here you go. This is the correct solution for part B. So like I said, the conjugate of 1 minus 2i is 1 plus 2i. So there's 3 factors you need. X minus 2 for that one. X minus 1 plus 2i for that one. And x minus 1 minus 2i for that one. Notice how the signs work out because you're subtracting this. It's negative 1 plus 2i, negative 1 minus 2i. I multiply these two first. I got x squared minus x minus 2ix and so on. You just got to be careful that you do every single multiplication correctly. After you multiply these two, always the i's, the terms that have I in them, should always cancel out. Notice how the negative 2ix and the positive 2ix cancel here. The positive 2i and the negative 2i also canceled. This one does not cancel, but it's I squared, which is negative 1. So it's negative 4 times negative 1, which became plus 4. And then everything else is x squared minus 2x. I put that 4 with that 1, and it's 5. Then I finally multiply the x minus 2 times that one, and I got this, which I combined the like terms, which is a negative 2x squared and the negative 2x squared, the 5x and the 4x, and I got my final answer, which is p of x equals x cubed minus 4x squared plus 9x minus 10. Right, I'm also going to let you guys work on C on your own. I'm going to help you guys out again by giving you what the conjugate should be. Remember, you must come up with these on your own though. So it's going to be 2 minus radical 5. Once again, these are not two separate zeros, two separate roots. This is one root, 1 0. The conjugate of this is 2. Don't change the sign of the first number, the constant. Change the sign of the irrational number. In this case, it's radical 5, so it's minus radical 5. Using these 3, go ahead and come up with the correct polynomial that gives you these zeros. Alright, here you go. This is the correct solution for part C. As you can see, I started by writing the 3 factors out for these, including the conjugate. I multiplied these two first. I just like in the last example, the radicals cancel out in this case. X radical 5 and negative x radical 5. 2 radical 5 and negative 2 radical 5 also cancel out. Okay. At the end of these multiplications, always the imaginary numbers or the radicals will go away. You should not have any left over. If you do, something went wrong with your multiplication. So double check every single one so you can see what the correct one is. Once I multiplied it all out and I canceled all those radicals. Also, don't forget that when you multiply radical 5 times radical 5, the radical just goes away and it's just 5. But since it's negative times positive, it's negative 5. Okay, so that's where I got that from. I combined it with positive 4, and that's where I got the negative 1 from right here. And then I multiply these two times each other. I got this, combined the like terms, which is the negative 4x squared and the positive x squared, the negative x and the negative 4x, and there you go. That's the final answer right there. Alright, number 15, simplify the expression. Assume that all variables are positive. All exponents should be positive in simplified form. Rationalize any irrational denominators. Okay, so just basically simplifying all these expressions right here. All of these have multiple ways of doing them. Okay, and I showed you guys a bunch of different ways. You could turn radicals into rational exponents like these, or you could turn rational exponents into radicals if you prefer. Okay, so there's a lot of ways, different ways that you could go about it. So you choose how you want to go about it. The point is to simplify it as much as you can so that you don't have these big giant exponents or radicals in the denominator. Alright, let's get started with A. In this one, what I'm going to start with is by writing the index here. You don't have to, but I like to know that the index is 2. And then I'm going to use the division method that I showed you guys. If I have variables inside with exponents, I can divide this number, the index, into each of these exponents to see what I get. So what I'm going to do is divide out the 2 into each one of these numbers in here. So the 2 goes into 3 one time, right? That means that the 1x goes outside, x to the 1. And the remainder, when you divide 2 into 3, is 1, right? 2 goes into 3 one time, remainder is 1. That means that there's 1x inside still. One single x by itself. Do the same thing for the y. 2 goes into 6 3 times, so that means that 3 y's come out. The remainder is nothing. 2 goes into 6 perfectly, so there are no y's left inside. So that's what comes out from the variables. The power is a little bit different. You have to factor that out, which I'm going to do right here, using a factor tree, which is 4 times 5. 5 is done. That's 2 times 2. So 2 2's and a 5. That means that one of these 2's is going to come out, and the other one's going to die. So there's a 2 that does make it out. 1 2. The other one dies. The 5 does not have a buddy, so it stays inside. There you go. Simplify it. Well, it's already simplified actually. The only thing is we got to do is get rid of that exponent, which is 1. So it's 2xy cubed radical 5x. Done. You don't have to write the index because the index is 2, so it's not necessary to write it in. There you go. Okay, part B, the fourth root of 16, a to the 8th, b to the 12th, all to the second power. I'm going to start this by turning this fourth root and second power into a rational exponent. So it's going to look like this. 16, a to the 8th, b to the 12th, to the 2/4 power. Right? The power is 2, the index is 4, so 2 over 4. Which really, you know what, let's go ahead and just simplify that already. That's just 1/2. To the 1/2 power. Makes it much faster. Now what I'm going to do is I'm going to take that 1/2 and distribute it inside of that parentheses, right? Power of a power rule and also the power of a product rule. Take that power and give it to each one of the terms inside of your parentheses. So it's 16 to the 1/2. A to the 8th to the 1/2. Remember the rule when you're sharing a power right there and it already has an exponent is to multiply. So 8/2, which is 4. A to the 4th. B to the 12th times 1/2 is 6. Alright, almost there. 16 to the 1/2 power just means the square root of 16, doesn't it? So this means radical 16, a to the 4th, b to the 6th. Notice that the radical that I wrote only covers the 16 because it's only, the 1/2 is only there with the 16. And the square root of 16 is just 4. So there you go, 4, a to the 4th, b to the 6th. Done. There are other ways you could have gone about this problem, right? For example, you could have found the fourth root of each one first, right? Divide in, 4 goes into 8 twice, so it's a squared that goes outside. 4 goes into 12 3 times, so it's b cubed that goes outside, right? And then taking care of the power that is outside. You would still get the exact same answer, though, if you decide to go that way. All right, let's look at C. Now, for this one, there's again, there's always many different strategies that you can use. I notice that they both have the same index, right? Index 2. So what I'm going to do is put them both under the same radical. You got to be careful about this. This is 27a cubed b squared over 3a to the 6th. But not the b. Notice that it stops right there before it actually covers the b. So the b is in a different fraction over here by itself. Okay? That way, when I'm going to do this, is I'm going to divide this, make it a lot simpler, and then I can just combine it with the b that is here. I did not put the b upstairs over here because it is in the denominator, so it must stay in the denominator. Now I'm going to simplify this by simply dividing. 27 divided by 3 is just 9. That's just 9. A cubed over a to the 6, ooh, that's going to be a fraction here, isn't it? A cubed over a to the 6. Remember the subtraction method, that's 3 minus 6, that's negative 3. But since it's negative, it goes down to the denominator. It's a cubed. B squared, there's no other b, so it just stays up there. And let's not forget the radical. 1 over b. Okay. What can I do next? Well, I can simplify the 9. Radical 9 is just 3, isn't it? So we can take that out over a cubed. Alright. Now, let's see. You know what? Let me erase this. I want to write it as 2 separate radicals now because it doesn't seem like I can simplify anymore. So it's going to be 3 radical b squared over radical a cubed times 1 over b. B right there. And I know I'm going a little bit sideways when I'm writing now. Oh, anybody else notice this? Radical b squared. That's just b, right? The square root of b squared. These two cancel each other, so it's just 3b. Alright, make it much simpler now. 3b over the square root of a cubed times 1 over b. Notice that there's a b in the numerator and a b in the denominator that can cancel, so it's just 3 over the square root of a cubed. Alright, almost there. Now I have a radical in the denominator, so we're going to rationalize it by turning it into 3 over a to the 3 halves. And remember what I showed you guys? You can rationalize it by multiplying times a power with the base a, but that will make this a whole number. 3 halves, how much more do you need to make it a whole number? You need 1 half. To make it 4 halves, right? 4 halves is 2. Alright. On the numerator, you're going to have 3a to the 1 half, which is just 3 radical a. In the denominator, you're going to have a to the 3 halves times 1 half is going to be a squared. Correct? Yes, I'm doubting myself now. A to the 3 halves plus 1 half is 4 halves, which is 2. Yes, a squared. Done. Okay, looking back at that one, I'm noticing that maybe I chose the slowest method. It looks like I had to take too many steps to simplify it. Maybe it's easier if you guys simplify each one individually by doing the division method, right? The index is 2, so 2 goes into 3 one time, take out 1a, and the remainder is 1, so 1a stays inside. Maybe that would have been easier. Or maybe it would have been easier to turn this into a power of 1 half, right? Square root means power 1 half, and then distribute the power 1 half to each one to see if you could simplify it that way. I don't know. It probably maybe would have been faster. Okay. Either way, this is the correct solution that happens after you simplify it. All right, D. I have m to the 3/4 n to the 1 half in the numerator, and then the third root of x to the 6th in the denominator. I am going to, let's see, leave this one alone. And in the denominator, x to the 6/3, right? Which is m to the 3/4 n to the 1 half over x squared. And I don't see anything else that we can do to simplify other than maybe changing this to radical form, right? The 4th root of m cubed times the square root of n all over x squared. And that's it, because the denominator is not a radical, so there's no need to rationalize it. Alright, either that or leave the exponents as rational exponents, and that's okay also. Okay, how about E? Looks pretty simple. Power of a power rule means that you need to multiply these two times each other. So negative 2 times 1 half is negative 1. So it's x to the negative 1. And that means the reciprocal, so it's 1 over x to the positive 1, which is just 1 over x. Done. Okay, for f, it looks like we have the cube root of 3, the cube root of 81, and the cube root of 243. Here's what I'm going to do. Since they're all cube roots, I'm going to put them all under the same index, under the same radical. So it's going to be the cube root of 3 times 81 times 243. Now you could multiply them out, but that would actually, if you do, you're going to have to factor it again later. So I'm just going to go ahead and factor it from here, right? I'm going to factor the 81. Now the 3 cannot be factored, so that's done. But I can factor the 81. Alright, make a factor tree out of the 81 to see what it gives me. And I know it's 9 times 9. And I know that 9 is 3 times 3, and the other 9 is also 3 times 3. So there's 4 3's that come out of that 81. And there's 1 3 that was already there, right? There's 1 3. There's 4 3's, that's 5. The 243 is also going to give me a bunch of 3's, I believe. Let me check. 243 is 81 times 3. There's another 3. And this is 9 times 9, which is 3 times 3 and 3 times 3 again. Look at that. Bunch of 3's. So how many total 3's do I have? 1, which is this one right here, the original radical 3 that was there. The 81 gave me 4 more, that's 5. And the 243 gave me 5 more, that's 10 3's in total is what I have. Nothing else. There are no other types of factors except 3's. There's 10 of them. Alright, so I'm going to make some space by erasing this factor tree here. What I really have is this, guys. I have the cube root of 3 times 3 times 3, a lot of them. How many? 10. I don't want to write 10 3's. Can I instead just write 3 to the 10th? Isn't that the same thing as 3 times 3 times 3 times 3, 10 times? So it's just 3 to the 10th power, the cube root of 3 to the 10th power. Now at this point you could group those 3's in groups of 3 because the index is 3. I keep saying the word 3, I'm getting tired of it. But instead what I'm going to do is divide it into. Say the index is 3. How many times does 3 go into 10? Oh, what a coincidence. 3 again. It goes into it 3 times, right? So that means that 3 3's go outside. And what's the remainder? When you divide 3 into 10, the remainder is 1. So 3 to the 1 stays inside. There you go. Now let's multiply those 3 3's that are outside. That's 3 times 3 times 3. That's 27. Finally, something that is not 3. There you go. Oops, I forgot the index. Very, very important, guys. The square root of 3 is not the same thing as the cube root of 3. There you go. 27 cube root of 3. Okay, let's look at G. The square root of 45, m to the 4th, n to the 7th. I'm going to start by making a factor tree for 45. It's 5 times 9. 5 is done. 3 times 3. Alright, so it looks like I have 2 3's and a 5. 2 of those 3's, these 2 3's will get together. One will come out. The other one will die, right? And the 5 will stay inside. The index, I didn't mention this, is 2, so that's why I'm only looking for pairs, right? Pairs of 2. The index is just 2. Alright, now what I'm going to do is use the division method. Since this is a number, this is a 2, I'm looking for how many times does 2 go into 4, how many times does 2 go into 7. And that's how I'm going to decide what comes out from the m and the 7. Okay, I think I'm probably going to need a little more space right here in front, so I'm going to move that 3 a little farther away. And then I will do the m and the n. 2 goes into 4 twice, so it's m squared. The remainder is nothing, it's 0, so there is no m left inside the radical. 2 goes into 7 3 times, so it's n cubed that goes out. And the remainder is 1. 2 times 3 is 6. The remainder is 1, so it's just n. There you go. That is completely simplified. Alright, h, again, looks pretty simple, just like a couple of examples ago. All we gotta do is multiply these two exponents, right? Power of a power means multiply the powers, multiply the exponents. So it's 5 times 3, which is 15 over 2. X to the negative 15 over 2. Which I am going to make a radical right now. I mean a reciprocal, so it's 1 over x to the 15 over 2. I can try to make this into a radical right now, but I don't want to because it's going to have a square root in the denominator, right? Which we don't want. We want to rationalize it. So I'm going to go ahead and rationalize it already by multiplying it by what I need in order to make it a whole number. This is not a whole number. How much more do I need to make this a whole number? Just 1/2, right? 15 halves plus 1/2 will make it 16 halves, which is a whole number. It's 8. So I'm going to just multiply times x to the 1/2 over x to the 1/2. And now when I put those together, in the numerator, all I have is 1 times x to the 1/2, which is just radical x. In the denominator, it's x to the 16 halves, which is x to the 8th. And that is 16. State the excluded values, if any. This one should be pretty simple. All you got to do is figure out what the excluded values would be. Remember, the excluded values are the ones that are not invited, that would ruin everything, right? So you look at the denominators and you set them equal to 0, as long as they have an x in it. If there's no x in the denominator, then there's nothing that is excluded. So look, let's look at A. X over x minus 5, pretty simple. Take the denominator, set it equal to 0. Whatever you get, which is 5, is the excluded value. 5 is excluded because if we invited 5 to this party, it would ruin the denominator. 5 minus 5, it would be 0, and you can't divide by 0. So we really should say that x does not equal 5, right? But 5 is the excluded value. B, super easy. Do you see an x in the denominator? No, you don't. So there are no excluded values here because there are no x's in the denominator. That is a horrible way of writing excluded values. No excluded values. Since there's no x in there, there's nothing that could ruin this fraction. You could plug in anything you want and it will still work because you're dividing by 10. Okay, C is a little bit more involved because there are x's in the denominator, which means that there are excluded values. We just got to figure out what they are. And so when you set this equal to 0, there's some work you need to do in order to figure it out. You need to factor this in order to figure out what the solutions of that equation are. So we're going to make an x factor. It's 2 times negative 3 is negative 6. B is negative 5. Two numbers that multiply to make negative 6, but combine together to make negative 5. I'm going to say negative 6 and positive 1. Right? Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Yep, that's correct. 2x squared minus 6x plus 1x minus 3. Now we're going to use factoring by grouping to finish it here. The first pair, the only thing they have in common, nope, they have two things in common, 2 and also x. So it's going to be x minus 3. The other two, the only thing is 1. So it's x minus 3 equals 0. So it's going to be the common factor that they have is x minus 3. Both of them have x minus 3. And the other remaining part is 2x plus, nope, not 3x, 2x plus 1 equals 0. Solve them both. You guys can do that in your head almost completely, always perfectly. X equals 3 and x equals negative, because you have to subtract the 1, 1/2. Those two numbers are the excluded values. These two are the ones that would ruin our equation, our expression here, if we were to invite them. So 3 and negative 1/2 would create a 0 in the denominator, so neither of them are invited. I'll let you guys figure out D on your own. I'm pretty sure by this time you guys can actually do it. Go ahead and pause the video, do it on your own, then come back and check it. There you go. There's the correct answer for D. Set the denominator equal to 0, you get 4x equals negative 3. Divide by 4, you get x equals negative 3/4, but again, it's excluded, so x does not equal negative 3/4 because it would ruin the denominator. 17. State the excluded values and then solve each rational equation algebraically. Alright, let's do it. Let's go to A. First, I'm going to find the excluded values. Pretty easy since it's already factored for me. That means that the first one is going to be 1. That's excluded. Also negative 4. And that's it, because that one's also going to give me -4, and that one's also going to give me 1. Okay, the denominators are already factored, which means that I can easily find the LCD by multiplying all the different factors. The LCD of this equation is going to be, I need x minus 1, right? How many of them do I need? Well, this one only has 1. This one only has 1. So the most that any of them have is just 1. So all I need is 1. X plus 4 is my other factor that I need. How many of them? This one only has 1 of them. This one only has 1 of them. This one has none of them. The most that any of them have is 1. So I only need 1 of them. That's it. That's my LCD. So what I'm going to do is figure out what exactly each of these fractions is missing in order to have this as the denominator. Okay. So for this one, it's not missing anything, right? We're going to leave that one exactly as is. X plus 6. Let me do all that in a different color so you guys can see it. It's going to be x plus 6. And then the denominator is x minus 1, x plus 4. Perfect. Done. The next one, the numerator is -6. The denominator is x plus 4. What is it missing in order to make it this denominator? It's missing the x minus 1, right? So I'm going to multiply it by x minus 1 over x minus 1. Come out a little more. The final fraction over here on the other side is 1 over x minus 1. What is it missing for the other denominators? It's missing the x plus 4, right? So I need to multiply it by x plus 4 over x plus 4. And now they all will have the same denominator, x plus 4 times x minus 1. So that means that you can actually stop worrying about the denominators. They're all the same. Just worry about the numerators at this point. X plus 6 minus 6 times x minus 1, right? Be careful, this is x plus 6 minus 6 times x minus 1, that's that part, equals 1 times x plus 4, which is just x plus 4. Alright, I'm going to distribute here. Be careful because it's -6, so it's going to be x plus 6 minus 6x plus 6, because it's -6 times -1, equals x plus 4. The 6 and the 6 together make 12. The x and the -6x make -5x. So -5x plus 12 equals x plus 4. Let's keep it going over here. I'm going to subtract x from both sides. Subtract x. That's going to be -6x plus 12 equals 4. I'm going to subtract 12 from both sides. -6x equals -8. And finally divide by -6. And I'm going to get x equals -4/3. Compare that to the excluded values from earlier, which were 1 and -4. There's no contradiction there, therefore that is your solution. Alright, let's look at B. 2x over x minus 5 equals 4x minus 10 over -x plus 5. First thing I notice is this just looks weird. If you have a negative as your first leading coefficient, go ahead and factor it out, make it a positive. Here's what I'm going to do. I'm going to rewrite this as 2x over x minus 5 equals 4x minus 10. If I factor out -1 out of this, doesn't that make it x minus 5 also? Like that. Which makes it so much easier. Alright, the excluded value is only one number. X equals 5. That one's excluded. The LCD is, we have to have an x minus 5. How many of them? Just one. This one only has one of them. This one only has one of them. You only need one of them. And also the -1. That's your LCD. Which means that this one's actually pretty simple. The only thing missing is in this one, it's only missing the -1 and that's it. This one's perfectly okay. That's the LCD that we want. So you want the first one, this one, to be multiplied by -1 over -1. and you want the other one to stay the same. Negative 1 times x minus 5. Now these cancel because they're exactly the same. So I'm going to continue here. Negative 1 times 2x is negative 2x equals 4x minus 10. Next, I'm going to subtract 4x from both sides. That's going to be negative 6x equals negative 10. We're going to divide by negative 6. And so x equals 10 over 6, which is 5 over 3. There you go. Compare it to the excluded value, which was positive 5. So no contradiction there. Your solution is correct. This is fine. Alright, 18. Kevin can clean a large aquarium tank in about 7 hours. When Kevin and Lara work together, they can clean the tank in 4 hours. How long would it take Lara to clean the tank if she works by herself? Alright, for this problem, what you need to know, the important fact to know, is that rates of work, of how fast people work, rates can be added to make a new rate. Times of work, of how long it takes somebody to work, cannot. Here's what I mean by that. If Kevin can clean the tank in 7 hours, cannot be added. And Lara can, let's say she can clean it in 3 hours. Let's make that up. Okay, Kevin can clean it in 7 hours, and let's say Lara can clean it in 10 hours, and 3 hours by herself. Does that mean that if they work together, it's going to take them 10 hours? No, that wouldn't make sense, right? If he can do it in 7 and she can do it in 3, why would it make sense for them to take longer if they're working together? If they're working together, they should be faster, right? Not slower. So the times that they work cannot be added, but their rates can be added. So here's what I mean by that. How fast can Kevin work? He can clean 1 tank. How long does it take him to clean 1 tank? In 7 hours. That is his rate. 1 tank per 7 hours. Or you can think of it as 1/7 of a tank per hour. Plus 1/7, plus 1/7, plus 1/7. So it'll take him a total of 7 hours to finish it. That's Kevin. What about Lara? Lara can clean 1 tank in, we don't know, that's the question. Let's call it T hours. T for time? Or H hours, or X hours if you want. But together, they can do 1 tank in 4 hours. And like I said, rates can be added. So we can say Kevin's rate plus Lara's rate is equal to their together rate, the total rate. So we can actually solve this equation now, okay? Kevin can do 1 tank in 7 hours. Lara can do 1 tank in T hours. Together they can do 1 tank in 4 hours. Kevin plus Lara is equal to their total rate together, okay? Let me rewrite that equation in a much simpler form. So without all that mess, it's 1 over 4 plus 1 over T equals 1 over 4. 1 over T. Whoops, I just messed up. It's not 1 over 4, isn't it? It's 1 over 7 for Kevin. 1 over 7 plus 1 over T equals 1 over 4. Alright, what you need to do is figure out the excluded value, which is 0. That's excluded. Which makes sense. It wouldn't make sense for Lara to take 0 hours to clean the tank. That means that she's super fast and she finishes immediately by just thinking about it. So excluded time T equals 0. The LCD in this case is 7. You need a 7. You need T. And you need 4. So it's 28T. That is your LCD. Okay. You can write it as 28T, or you can write it as 4 times 7 times T. Either way is the same thing. Actually, it's probably better if you write it like this, because then you can tell exactly what's missing from each one. All right, so we need a common denominator. I have 1 over 7. What's missing from that one to turn it into 28t, or to turn it into 4 times 7 times t? 4t, right? It's missing a 4, it's missing the t. 1 over t. What's missing from that one to turn it into 28t? 7? No. 28. It's missing 4 and 7. Okay, so it's missing 28. Equals 1 over 4. What's missing from that one to turn it into 28t? 7t. Right? So each one of them is missing something. Now, after I multiply these out, notice that all the denominators are going to be the same. 28t, 28t, 28t. That's what we wanted, because now we can stop worrying about them. It's just 4t plus 28 equals 7t. I'm going to subtract 4t from both sides, and it's 28 equals 3t. And I'm going to divide by 3. And there's your final answer, 28. So it's 9.3 hours. Which actually makes sense, guys, because that means that if Kevin can do it in 7 hours, but together they can do it in 4 hours, that means that he's saving 3 hours by getting Lara to help him. So she must be a little bit slower than him, right? If she was faster than him, then this would be a much smaller number. It would be less than 3.5, right? So he's not saving that much time, but he's saving in a lot of time by having her help him. You know what? I am going to stop this part 2 right here on problem number 18, and I will do part 3, the last one on the last page of your review. I'm thinking tomorrow that will be posted. Okay, so this is the conclusion of part 2. Part 3, which is on the last page, will come tomorrow.